Assalamualaikum and good morning to Madam Aisha. So today I'm going to present about our paired assignment for SCA206. This is prepared by me, Afiq. So this is my paired assignment, which is Amir Iqbal bin Amiruddin. And next is going to be a question that is given by Madam for our paired assessment. Question 1 is about joint probability distribution, while question 2 is about joint probability density function. And next is question 1. Question 1 contains from A to E, where you have to find the probability distribution of X and Y. So this is going to be answered by Amir Iqbal, and I'm going to pass it to him.
Assalamualaikum and hello, my name is Ahmad bin Amiruddin. I'm from group N for CS1123C, and we're diving into discrete joint probability problem. Our first task is finding C, since sum of all probabilities in the distribution must equal 1. We sum X plus Y for every possible pair. The total sum of these terms is 27. So 27C equals to 1, making C equals to 1 over 27. Next, we map this out into a joint distribution table. By summing across the rows, we find the marginal distribution of X, and by summing down the columns, we find the marginal of Y. For X, probabilities are 2 over 9, 1 over 3, and 4 over 9. Even though Y has different values, which is 1 to 3, its probabilities follow same pattern due to a symmetry function. So moving on, are X and Y independent? To check, the joint probability must equal the product of marginals at every point. We tested the point 0, 1. Since 1 over 27 does not equal 4 over 81, we can confidently say X and Y are dependent. They influence one another. Now, what if we know X is exactly 2? We calculate the conditional probability that Y less than 3. We look only at the row where X equals to 2 and some of the cases where Y is 1 over 2. Dividing joint sum by marginal probability of X equals to 2, we get 7 over 12. Finally, we look at variance and expectations. We calculate mean and EX squared to find variance of 50 over 81 for both variables. To solve complex expression, E for X squared plus 6Y minus 2, we use the linearity expectation. We break it into parts, plug in our calculated values for EX squared and EY, and simplify to final answer of 178 over 9. That concludes analysis of question 1.
So next is question 2, consists of from A to D, which is the joint probability density function. It's going to be answered by me.
Assalamualaikum and good morning. My name is Mohamed Ahmad. My student ID is 2024236966. So as we can see, I'm gonna answer question 2, and this is the explanation for it. So this is a question about how do we set up the boundaries for our integration. So firstly, we determine the limits of integral by looking at the domain, and we define that is defined in the problem that in the image the function fxy is only active within a specific rectangular region in the xy plane. So our goal is to ensure that the total volume of this shape equals to 1, and then extract the individual characteristics of X and Y. So first we find K. For any joint PDF, the total volume under the surface must exactly be 1. So I set up the double integral with limits 0 to 1 for X and 0 to K for Y. So after integrating X first, I was left with the quadratic equation K squared plus 4K minus 12 equals to 0. Solving this gave me K, and we ignore the negative result because the probability range cannot be negative. And then next is finding the marginal. So next we look at the marginal identities, And we think of this as collapsing the 3D shape into a 2D shadow. So to find fx, I integrated the joint function with respect to y over its range from 0 to 2. Whereas to find fy, I integrated with respect to x over its range from 0 to 1. So this gives us the individual behavior of each variable. Next is to check for independence. So now x and y independent. To check, multiply two marginal results together in a perfectly independent system. So fx times fy should equal to the original joint function. Since they didn't match in this case, we can conclude that x and y are dependent, meaning the value of one provides information about the other. So lastly, for mean and variance of p, we can calculate the mean of variance for the linear combination of p equals to 6x minus 3y plus 4. For the mean, I use the property of linearity of 6ex minus 3ey plus 4. Whereas for the variance, it is a bit trickier because they are dependent. So I use the formula that includes the covariance, which is variance p equivalent to 6 squared variant x plus negative 3 squared variant y plus 2 times 6 times negative 3 covariant xy. After calculating the individual expected values and the covariance, the final result for the mean is 5 and the variance is approximately 4.733. And that is all from me. Thank you very much.
And that is all from us. Thank you very much.